Hey, welcome to the next presentation on measurement. This is an interesting one, very important in a lot of aspects of building. It's on scales and ratio. And look around the screen there, I think you can see the idea that when planning a home, people don't actually make models of the home and try to work out whether bedrooms are big enough or whatever. They draw a floor plan, and they have a scale, so they reduce down the size of the house so that they can actually work with it on paper. Or now, of course, there's computer modelling. A bit redundant now, some of this stuff. But you can't actually get out on the block and paste it all out to see if it'll all fit on the block or whether the family room's big enough and all that. So we draw a scale diagram. Okay, and here's another little plan here, reduced down to 1/400th of its size. They actually got the measurements in here, or most of them, reduced down according to 1 to 400. So that's what we're going to look at, a scale and a ratio. And let's come on down and have a look at the idea of that. And this little picture taken here from Hayes and Harris Publications. And if that's the actual size, you might want to enlarge it by 150%. That means your enlargement factor E, you'll times everything by 1.5. Make it bigger. You might like to do that when you're looking at your biceps. You probably need an enlargement factor of even greater. Sorry about that. Then under a 70% enlargement, 70% is less than 1, so the enlargement factor is 0.7. So you're multiplying everything by 7/10, it's going to shrink. Okay, so that's what we do. This is normally what we do in floor plans and stuff, and in surveying, all that sort of thing, making plans that you can work with without actually going out and doing the overall big measurement and planning. Plan it on a piece of paper or a drafting board in an office. Okay. Well, let's have a look at the idea there of how we do that mathematically. A scale ratio is a way of showing the enlargement. So what you put in there is something, and we read this as 1:2. That's how we do that. That's how we read that ratio symbol there. 1:2, let's say 50, means 1 unit on the drawing represents 50 times as big in real life. 1:50, we say. 1:100. If you read 1 centimetre, if you measure 1 centimetre, that's equivalent to 100 centimetres, or 1 metre's worth in real life. Okay, 1:100. Here we are, down here. 1:50. Remember, when you say this, it's as 2. 1:2. So it's saying 1 on the diagram is as 2 as to 50 on the actual length. 1:1 means it's the actual size. The plan is drawn to full size. Okay, so let's. That's as simple as as difficult as it gets. It's pretty simple. So let's have a look. Length measured on a drawing. 60 millimetre, 1:100, it'll be 100 times that. 100 times 60 is 6,000, therefore it's 6 metres from our conversions earlier. 25 millimetres on a diagram, 1:50, multiplied by 50, it's 1,250 millimetre. Well, what is that? Divide by 1,000, that's equivalent to 1.25 metres. 6 millimetres, 1:1. Hasn't changed. 1:1 means 1 on your diagram is equivalent to 1 in everyday life. That's a full size. Okay, so that's all there is to it. So let's have a look at some problems from Hayes and Harris Publications. Now, in all these problems, when I've created this video, there's been a bit of an enlargement factor from the textbook. Otherwise, it wouldn't be very readable. So you'll have to go to the textbook and do your measurements from there if you want to match up with the answers that they have that I'm giving down below. So you won't be able to do it off the screen because it's been changed in size already. So this sort of thing you can do either way, just to get an idea of how you would go about enlarging that by a scale factor of bigger than 1 where it gets bigger, or less than 1 where it gets smaller. Okay, and we've got standard questions here that we've just had a look at. Okay, remembering the first number is what's on your drawing, and you have to multiply it by the enlargement factor. It'll be bigger in actual length there. Okay, come down now, let's look at a few other problems. Question 3. Maybe just have a go at those. Again, measuring these lines will have to be done from the book because this has been enlarged now, if you want to get the answers that I'm going to show you in a minute. Alright, so pause the presentation, have a go at those 3. And here are the answers they have. You'll only get these down here if you have measured from the actual textbook. Okay, let's move on and see some more interesting stuff. Here's an example here, and a question for you. The outside house wall of a house is 15 metres long. What line length will be used to represent the wall in millimetres if a 1 to 100 scale is used? This is going backwards now. So we've got to work in millimetres. So let's take the actual length. How many millimetres is that? Well, it's 15 metres. There's a lot of millimetres. 15,000 millimetres. Now, if we're reducing it, because this is our measurement and the actual measurement, so we have to divide by 100. We're going backwards now. So we will have 150 millimetres of length on our diagram. Okay, this is backwards now, reducing it down. So what are the steps? Look at the units you want to use on your diagram, make your actual length into those units, and then divide by 100, because you're going backwards from this 1 to 100 scale. Okay, do you get it? Have a go at this question. These two actually, question 4 and 5. See what you think. Okay, and that's question 4. That's an important question because you actually do have to do that if you're going to produce a scale drawing, don't you? Once you're reading a scale drawing and multiplying it up to get an idea of the actual lengths, that's going the other way. But you'll have to go out on site and measure the distances and reduce them so you can draw diagrams back in your office if you like. Okay, let's go on and see a further application here, a bit more practical now. Here's a scale drawing of a building, and you'd use measurement, use your ruler and this given scale to find the height and the width. Okay, so on the diagram you measured that the height is 25 millimetres, scale is 1 to 200, so the actual size is 200 times your drawing. 5,000 millimetres divided by 1,000 is 5 metres. Measuring on the diagram, the scale width is 56, multiplied by 200, because the actual size is 200 is big, that many millimetres, 11.2 metres. Okay, notice that it is important after you do the multiplication to bring it back to a realistic measurement. We don't usually speak of 11,200 millimetres. Divide by 1,000 to get metres. Okay, alright. Let's have a look, give you a go. Now you'll have to do this from the textbook. Question 6, I'll put the answer right there for you. Okay, the scale given is 1 to 2,000. You need to measure all of these from the textbook because it's already been enlarged. Okay, see if you can get those answers there. Let's keep going with that idea and have a look at this drawing now. Now, scale is 1 to 400, so you have to measure this from the textbook, but a lot of the lengths are already given across here. Now, you have to work out the ones that are missing, okay, in working out the dimensions of the block. Okay, so anything missing, you'll have to measure and use this scale. Okay, fair bit of work on that one. Okay, I'll show you the answer in a minute, but let's have a look at another one. Question 8, small holiday house and the floor plan. So you need to actually again measure this, and there's the scale. Measure it from the textbook. Okay. Let's go to the last one now. Question 9. Diagrams there. You have to take those from, I haven't got those on there. Find rise and plan elevation of the proposed extension to a house. So you'll have to take those from the textbook. I haven't produced them here because you'll need to measure it from the textbook. Okay, let's have a look at the last answers there. This is a very useful activity because it is used in industry and planning and building. Alright, I hope you were successful with that. We're going to go on in the next presentation with some other surveying and measurement type ideas with perimeter, area and volume. So I'll catch you then. Cheers for now.